Good morning. Welcome to the course Information and Communication Theory. I am Dr. Dutt Joshi, Associate Professor in the Department of ECE, TIET, Patiala. This is Lecture 1 of Module 2 Information Theory. This course is divided in 5 modules. In Module 1, we have studied the basic of probability theory, the basic concept of random variable, their distribution function, their moments, characteristic function, and central limit theorem. In this module, that is information theory, we will study the basic concept of information, how to measure information, the concept of average information, that is known as entropy, the source encoding, mutual information, and channel scarcity. We will also study different Shannon's theorem. And from module 3 to module 5, we will study the stochastic process, the concept of estimation and hypothesis testing, and statistical modeling of noise. So, following are the contents of lecture 1. In this lecture, first of all, I will briefly explain the block diagram of general communication system. After that, we will gradually move towards the information theory. We will study the importance of information theory, the historical origin of information theory, and then we will study the relationship between information and uncertainty. After that, we will study the information measure, that is the mathematical definition of information. So, this is the general block diagram of any type of communication system. I will explain each block one by one. So this is a conceptual block diagram. The detailed sub blocks of transmitter or receiver or information source is not given here for the sake of simplicity. So the goal of communication system, the goal of any communication system is to transmit information from source to destinations. Now let us start from the first block, that is information source. The information source generates some random messages for the transmissions. The types of message that can be generated from information source are audio signal, video signal, image data, or text messages. So nowadays, when we are calling someone through our mobile, then we are sending audio signal. When we are doing video conferencing, then video signal is transmitted along with the audio signal. When we are sending an image through our email, then both text data and image data is transmitted through our computer system. So different types of messages that can be generated from an information source are audio signal, video signal, image, and text data. Now, two types of information sources are available: the source with memory and source without memory. The source without memory is known as memoryless source. In the memoryless source, the information source generate independent random messages. So every message are independent to each other. Whereas in source with memory, that is known as Markov source, it generates dependent random messages. So each symbol or each message that is currently generating, it depends on the previous symbol or previous state of the source. The next block in the communication system is transmitter at transmitter side and receiver at the receiver side. So the function of transmitter is to process the message that is generated via the information source so that it can be transmitted efficiently through the channel. So it apply some signal processing to make it suitable for the transmission through channel. At the receiver side, receiver receive a noisy signal. Why it receive noisy signal? Because when a process signal is transmitted through channel, the channel adds some noise in this transmitted signal. So receiver receive a noisy signal from the channel. Now what is the task of receiver? The task of receiver is to apply some signal processing to correctly estimate the transmitted message. So it perform reverse of transmitter, or we can say that it perform the inverse function of transmitter to reconstruct the original signal. After that, receiver transmitted this message to final destination. Next block in this communication system is channel. Channel act as a medium of transmission. Through channel, the signal from transmitter is transmitted to the receiver. So, channel act as a medium of transmission. Two types of channel are there. Channel may be wired or wireless. So, depending on the channel, any communication system can be classified either wired communication system or wireless communication system. If physical medium of transmission is available, then it is called wired communication. And if free space is used as a medium of transmission, then it is called wireless communication system. The example of wired communication system are telephone communication system, cable TV transmission system, local area network, it is called LAN. In telephone communication system, the two-wire transmission line is used as a channel. In cable transmission system, the coaxial cable is used as a channel, and in local area network, Ethernet cables are used as a channel. In wireless communication system, free space is used as a channel. So, in wireless communication system, our transmitter required antenna for transmitting the electromagnetic waves to the receiver. Receiver also require antenna to convert these electromagnetic waves into the electrical signal. So the example of wireless communication system are cellular network, or more commonly known as mobile communication system, satellite communication system, FM broadcasting, AM broadcasting, and television broadcast system. So that is all about the communication system. Now, the major objective of any communication system is, whether it is a wired communication system or wireless communication system, the major objective of any communication system is to transmit information with following objective: with maximum data rate, we required as much as high data transmission rate, with minimum probability of symbol error. It means we required correct transmission. Whatever we are transmitting, it should be correctly decoded at the receiver. So the probability of symbol error should be minimum. Then we required minimum transmitted power, because all these things are very important when we are designing any communication system. Now the questions are: how much maximum data rate can be supported by any communication system for reliable communication? So this is the first important question, and this focus on these two things: how much maximum data rate and what is the minimum probability of symbol error. And the next questions are: what is the measure of information? It means if you are transmitting information, how we can measure the information, how we can listen. These are the two fundamental questions that can be answered only by the information theory. So now let me move towards the basic of information theory. So in particular, information theory answers two fundamental questions. First question: what is the irreducible complexity below which a signal cannot be compressed? The answer is entropy of a source. I will explain in the later part of this lecture what is entropy and how it is related to the compression of a data. So this question is basically related to the first question that we have asked here: what is the measure of information? So what is the irreducible complexity below which a signal cannot be compressed? The answer is entropy of a source. And the second question, what is the maximum transmission rate for reliable communication over a noisy channel? And the answer is capacity of a channel. So I will explain in next lecture of information theory that how the maximum transmission rate is related to the capacity of a channel. In general, information theory deals with the mathematical modeling and analysis of a communication system rather than with physical sources and physical channels. So that's why I have not shown the detailed sub-blocks of transmitter and receiver which are using for signal processing purpose. So information theory or basically gives the mathematical concept behind the communication system. Information theory also deals with the amount of information contained in any random signal, that is known as information measure. So information theory gives the unit of information. So with the unit of information we can measure how much information we are transmitting. We can measure, we can calculate the transmission rate of our communication system. Information theory also deals with the relationship between the signal to noise ratio and channel capacity, or we can say it gives a relationship between the noise power and the channel capacity. It also deals with the relationship between channel bandwidth and channel capacity. So that is all about the basic of information theory or what we can do with the information theory. So before starting the basic of information, that is information measure, let me briefly study the historical origin of information theory. The main concept and principle of information theory were developed by Claude E. Shannon in late 1940s. He published a paper titled as A Mathematical Theory of Communications that is published in Bell System Technical Journal in 1948. He did mathematical modeling and analysis of communication system and postulates many theorems that is related to information theory. Claude Shannon was an American mathematician, electrical engineer, and a cryptographer, and famously known as the father of information theory. He published this paper when he was working with the Bell Labs. So, the major contributions of this paper are source coding theorem, channel coding theorem, and he established a relationship between signal to noise ratio and channel capacity, channel bandwidth, and capacity. So that is all about the historical origin of information theory. Now let me understand what is information and how information is related to the uncertainty. Consider following sentences. The sun rises in the east and set in the west. So this is highly probable event. The probability is 1 because we know that sun rise in the east and sun set in the west. There is no questions about this event. The second sentence is dog bites a man. So it may happen. Now let us understand what is information and how information is related to uncertainty. Consider following sentences. The sun rise in the east and set in the west. This is highly probable event. So the probability of occurrence of this event is 1. Second sentence, a dog bites a man. It may happen but not frequently. So this event is associated with some probability or some uncertainty. Third sentence, there will be a less rain in Patiala in this rainy season. It may also happen, but not guaranteed. Hence, it is also associated with some probability. Fourth sentence, man bites a dog. So, this is rarest event. So, it is highly uncertain. The probability of occurrence of this event is very less. And the last sentence is, the Thar desert will receive heavy rainfall in this rainy season. So, this is also a rarest event and it is highly uncertain. The Thar desert may receive rainfall, but the chances of heavy rainfall is very less. So, from these sentences, what is the intuitive feeling about the information, or what inference we can draw from these sentences? Let us see. Intuitive feeling. The first inference that we can draw is that information contained in an event is closely related to its uncertainty or probability. Second inference that we can draw, that message with the low probability contains high amount of information, and message with high probability deliver very low amount of information. So from these five sentences, the first sentence have a high probability. The probability of occurrence of that event is 1, because we know that sun rise in the east and sunset in the west. So if somebody gives you this news, then it will pass on zero information to you. And the sentence like man bites a dog, it is a rarest event, and if somebody gives you news, then it passes a large amount of information. So the inference is that the message with low probability contain high information and the message with high probability contain low information. And before the event occurs, there is some amount of uncertainty in that event. After the occurrence of that event, there is no uncertainty anymore, but there is a gain in the amount of information. So there is a inverse relationship between uncertainty and the information. So we can conclude that the amount of information should be inversely proportional to the probability of message. After these logical explanations of information, we can now define the information mathematically. So this is the mathematical definitions of information. Let xj is an event with a probability pxj, then the amount of information associated with the event xj is given by these expressions. As we know that information is inversely proportional to probability of an event, now we have associated one function, that is logarithm function, with the information. So information is defined as ixj is equal to log of the base b 1 upon pxj, where pxj is the probability of event. Now this choice of base for the logarithm define the different unit of information. This is also known as self information. When the base is 2, then the unit of information is bit. When the base is e exponents, then the unit of information is net. When the base is 10, then the unit of information is decit or Hartley. So there is a relationship between Hartley and bits and net and bits. So most common unit of information generally used are bit. So 1 Hartley is equal to 3.32 bits and 1 net is equal to 1.44 bits. Now we can define the properties of this
mathematical definition of information. So this is the definition of self-information. Self-information in the event xj, that is represented by ixj. Ixj is equal to log b 1 upon pxj, where pxj is the probability of that event and b is the base that we are taking to define this information. So if base b is 2, then the unit of this information is bit. So this definition satisfied following properties. The first property, ixj is equal to 0. It means the information contained in any event xj is equal to 0 if the probability of that event is equal to 1. It means the certain events convey no information. So two types of events are there, the certain events and uncertain events. The certain events means the probability of that events are 1. Second property, the information contained in xj, that is represented by ixj, is always greater than or equal to 0 for, because pxj is always lies between 0 and 1. It means every event that happen or that occurs provides some information and never bring a loss of information. It means self information can never be negative. Third property, so information contained in event xj, that is represented by ixj, is always greater than information contained in event xk if pxj, when the probability of event xj is less than the probability of event xk. It means the less probable event convey more information and high probable event convey less information.
Now the fourth property is about the joint events. If two events xj and yk, independent events, if two independent events xj and yk occurs simultaneously, then the total information that convey by this simultaneous event is the sum of information in these two independent events. That is, mathematically we can say that I xj comma yk, that is the joint event, is equal to information contained in xj, that is represented by ixj, plus information contained in yk, that is represented by iyk. And this property hold when both event xj and yk are independent. So we can say that information is additive in nature. Now the question is, why logarithm is used to define the information? Because logical explanation is that information is always inversely proportional to the probability of an event. But why information is equal to log 1 upon probability? So let us see the reason behind it. The logarithm measure is justified by the desire for information to be additive, as we have shown in the last property that information is always additive in nature. Now let us see this case. When two independent events take place, then the total information is sum of information in each event. That is the fourth property. That fourth property is explained. But the probabilities of independent event multiply to give their combined probability. We know this property already, that if two independent events occur, then the joint probability is equal to the product of individual probability. Therefore, we must take logarithm in order for the joint probability of independent events or message to contribute additively to the information gain. Now let us understand this concept mathematically. Let xj and yk are two independent events. with the probability pxj and pyk, and self information associated with them is ixj and iyk. Let ixj is some function of 1 upon pxj, because information is inversely proportional to probability, so we take ixj equal to f1 upon pxj, and information contained in yk is equal to f1 upon pyk. F is some function, so information contained in xj and yk is a sum function of probability, and it is inversely related. Then the probability of joint event is defined as p xj comma yk, and we know that these two events are independent, so pxj comma yk is equal to pxj multiplied by pyk. So the joint event, the probability of joint event is equal to the product of probability of independent events. So the information associated with this joint event is defined as I xj comma yk. So now we are defining in the same way as we have defined the self information, information related to some function with the inverse relationship with the probability. So information with this joint event xj comma yk is also related to some function f1 upon pxj comma yk. But we know that pxj comma yk is equal to pxj into pyk, and we already know that the total information is sum of both information ixj and iyk. This total information ixj comma yk must be equal to the sum of individual information ixj and iyk. So ixj comma yk, that is the information in joint event, is equal to f1 upon pxj multiplied by pyk, should be equal to function f1 upon pxj, that is the information in xj event, f1 upon pyk, that is the information in yk. So from this expression it is clearly visible that we require a function which convert this multiplication or this product into addition, and logarithm is one such function. So if I apply f is equal to log, then log 1 upon a into log 1 upon b is equal to log 1 upon a plus log 1 upon b. So finally we can define information in the joint event I xj comma yk is equal to log 1 upon p xj into pyk, because these two events are independent. So basically we have to put here I xj comma yk is equal to log 1 upon p xj comma yk, because pxj comma yk is equal to pxj into pyk, because these two events are independent. So the joint information is equal to log 1 upon pxj into pyk. Now log a into b is equal to log a plus log b. So log 1 upon pxj plus log 1 upon pyk, and log 1 upon pxj is equal to information in event xj, and log 1 upon pyk is the information in yk iyk. So in this way we have proved that why logarithm is used to define the information.